Hello again, sick, twisted weather freaks. On this Friday evening, this January 3rd, the Arctic front has come through the East Coast, and I'm going to do a special video just on the January 5th, 6th event based upon the midday models here on Friday, January 3rd, and the evening models as well. This is being done before the 0Z GFS model comes out, so we're looking at that kind of data. So let's begin here. Now, I posted this earlier. I want to show you what the problem is. Essentially, what we're looking at is the GFS model against the world. The GFS continues to have a solution that no other model is showing. Now, again, the purpose here, I'm not trying to convey to you, this map here is the upper air map. These are 500 millibars, and it's vorticity, the spinning motion of the atmosphere. That's what the reds and the yellows and the browns are. Right? And the black lines are the height lines, which approximate the jet stream. Jet stream is actually about 200 millibars, but we use 500 millibars. Okay, what I'm trying to get across here is that the GFS does something with this storm that no other model does, and it pulls it further to the north, which allows more warm air, more sleet, a quicker changeover to rain in the southern half of Virginia, and then also more sleet and less snow into northern Virginia and Maryland and D.C. and Baltimore and the D.C. metro suburbs and so on and so forth. So that is a wrong solution. I'm going to show it to you why it's a wrong solution. Now, you might initially say, well, you just want more snow in Virginia. Okay. What we're doing here is science, all right? And whatever the data takes us is where the data takes us. Now, I'm going to make the argument, and if you think this is simply just, an effort to say that the GFS is wrong because I don't like the solution, that's fine, but just do everybody a favor, then just stop watching the video. So here we're going to do the science, and let's take a look at this and see what's going on. So, as you can see here, on this image, on the left-hand side, it was the early morning GFS model, and on the right-hand side was the 12Z run. And what I wanted to point out here, oops, sorry about that, let me call up a marker so we can see what exactly I'm referring to. Here we go. So this piece of energy here, see the blue circle? That is a closed 500 low. Now this feature is very strong in Missouri and Illinois. A lot of the models are. But when it moves east, it runs into this gargantuan upper low here in southeast Canada. And that forces the system to weaken. But not according to the GFS. See, this has a big closed 500 low covering the entire state of West Virginia. What that does is that captures the surface low in Tennessee and it pulls it northward. And when the low comes northward, it pulls the warm air up from the Carolinas into Virginia, Maryland, Delaware. That's what it was doing. Here's the 12Z GFS. Now here, the 500 low is a little weaker. So it looks like it's beginning to cave in to the European, the Canadian, and the British models because this feature is now much smaller here. So that was a good sign that it was doing it. Okay, and of course the GFS was turned significantly colder now in much of Virginia. A lot more ice, less rain, and more snow. The problem is, okay, when you look at the GFS ensemble, it doesn't have that solution at all. Now this is from concentrating here on the right-hand side. This is valid for Monday evening, okay, January 6th. Now take a look at this feature here, see where this is. Now take a look at this. That's not the same thing, not even close. And whenever you have a model, whether it's the Canadian, the European, the British, the Japanese, whatever model you want to use, okay, and the ensemble and the operational models are this different, that's always a sign that the operational model is full of shit. That's essentially what it is. So this is a very bogus solution here. Now, I'm not going to say it can't possibly be right. Maybe the GFS could be right. I just don't think it is. All right? Okay. Now, to show you what I mean, here's the GFS. This is from Friday midday, 12Z. This is the noon run, okay? See the surface low is in West Virginia. You see that? Look where the rain line is. It's north of Fredericksburg. And you have the snow line is almost on the Pennsylvania-Maryland border. D.C. and Charlottesville and Winchester and Harrisonburg, they're all sleet and freezing rain according to this model. Okay? And also, notice you have a big dry slot here. Okay, when the low tracks up towards Pennsylvania, get this dry slot coming up from North Carolina and Tennessee all the way into Virginia. Okay, this is bullshit. And I'll show you why in a second. Now, here's the 12Z. This is the 18Z GFS that came out at 6 p.m. This is valid for 2 p.m. Look at the temperatures in Richmond, you're 37 degrees. He's 34 degrees, 38 in Roanoke. You can see the mild air coming up. Now, D.C. is still 30 degrees, okay, and Charlottesville 31. So if this is sleet, if this is not snow, this is sleet and freezing rain. And then you're in the upper 20s, mid-20s in Winchester and Hagerstown and most of Maryland, into Philadelphia, northern Delaware, southern New Jersey. All right. Now, this is the Canadian model. Same time frame. This is from midday on Friday, okay, only 6 hours ago. Look at the upper low. There is none. You see? Look. No closed low here. I'll see that? None. Canadian says GFS. Okay, well, we have a difference in models. Okay, let's see what other models are showing. Here's the European. Look, no closed 500 low. European, GFS. Okay? GFS, European. These are not the same thing, boys and girls. That's the Canadian, and this is the European. Not even close. They're just not the same thing. Notice the 500 low is not in West Virginia or Ohio, Kentucky. The main vortex is in central North Carolina, hundreds of miles further south. So, okay, and that's the big difference. And here is the British model, which is very good, arguably the second best global model in the world, right next to the European. And look, no closed 500 low, and look at the main piece of energy, the purple red area in North Carolina, which looks like the European model. See that? And that's one of the reasons why the Hurricane Center likes using the British model and gives it so much a weight when it's doing its extended forecasting. So you can see what the British model is doing. So, and again, notice the huge 500 low here, just north of Montreal. See this? That is suppressing this system flat. The GFS doesn't see that. The GFS is badly designed in this regard, and it's taken the 500 low and moving it towards this, moving it towards the upper low over Montreal. That cannot happen. That is against the wave laws of physics. So that's why the GFS is bogus. And on top of that, no other model shows it. So when you've got one model showing XYZ and you've got 5 or 6 other models showing ABC, go with the ABC. Okay? All right. Now, here's the European solution. Now, this was the GFS. This is from 12Z. This is midday. Remember, we just looked at this, right? See the low in West Virginia? See it? Here's the European. Oh, no, it's in Asheville. Huge differences. That is not the same as this. Huge differences. Absolutely massive. So there you go. Okay. And then, okay, well, let's take a look. Now we got the 18Z GFS that just came out at 6 p.m., 6:30, 7 p.m. this evening. And sure enough, guess what? It's got a closed 500 low again in West Virginia. Well, when you look at the 18Z ensemble, what does it have? Doesn't have that. So again, this doesn't match this, and it's supposed to. These are the same models. GFS, GFS ensemble. GFS, GFS ensemble. They're supposed to match, and they don't. Not a good sign for the GFS, boys and girls. Okay. Now here is the 18Z European. And look where the dark red area is. Again, central North Carolina. No closed 500 low. This is very consistent with the previous run. So there you go. There's the consistency. And sure enough, here's the GFS at 18Z. Okay? This is valid from Monday morning at 10 a.m. Look where the low is. Oops, that's not it. Get rid of that. Sorry about that. I wanted to put a marker here. Okay, let me call it up here. You can see it. Okay, so here is the low near Charleston, West Virginia. See that? Okay, this is 10 a.m. on Monday. And you can see that southeast Virginia, all North Carolina, Roanoke's gone over the rain, Richmond's gone over the rain. You have a big heavy ice storm in the northern Virginia, Piedmont, and D.C., and northern Shenandoah Valley. And then your snow is, again, up by the Pennsylvania-Maryland border. Again, I think this is bullshit, but we'll see. Okay, now let's look at the 18Z European. Oh, again, Asheville. Totally different solution. Totally different solution. Much colder, much snowier. Yeah. That's why you're getting such big discrepancies in the snowfall maps. Again, 18Z GFS came out 6 p.m. European. Big differences. And again, the GFS solution does not have any support. All right, let's look at the 12Z European and see how this unfolds. This is Sunday evening, 7 p.m. So here is the Let me call it a marker here so you can see it. I'm going to change the color in this thing a little bit so you can see it a little better. Okay. 7 p.m. Okay, this is light snow, the light blue. This is moderate snow in here. And this is heavy ice in in eastern Kentucky. So you can see it's already snowing now. Roanoke's maybe getting some snow. Certainly Smith Mountain Lake, Lynchburg, pushing into the Virginia Piedmont, maybe Farmville. That's where you can see it breaking out. This is Sunday, 10 p.m. It's advancing north. It's now in Richmond, east of Richmond. And you have moderate snow getting into maybe Lexington. You can see central West Virginia is getting snow. Okay, and so on and so forth. Look at the heavy ice in southeast Kentucky, and then southwest Virginia. That dark pink stuff is heavy ice. And we'll get to that in a minute. All right. Then you can see the temperatures. This is Friday. This is the midday Friday, the 12Z run Friday. Look at the temperatures for, this is 12 a.m. Monday morning, January 6th. Richmond is 30, 29, 30 in Blacksburg, Roanoke. You can see the mid-upper 20s. Everybody's below freezing except for Hampton Roads. Okay, so this is all cold enough to support frozen precipitation. Now this is Monday morning at 4 a.m. Look at the ice storm in Roanoke. Holy crap! Okay, Bluefield in southeast portions of West Virginia, Smith Mountain Lake, Lynchburg, and the ice expands over towards Nottoway and Emporia and maybe Blackstone, places like that. They're getting hit with the ice. Richmond is a combination of snow to the north, sleet and freezing rain to the south. You can see heavy snow into Charlottesville and Stanton at that point. And then you can see moderate snow has now reached D.C., and moderate to heavy snow in Fredericksburg and Warrenton and Culpeper, western Maryland. Look at central West Virginia getting blasted, and southern Ohio. Nice storm. All right? Here we have Monday at 10 a.m. on the European. This was as of 4 a.m. This is 10 a.m. Okay? Now Richmond is getting cold again. You can see the heavy snow just north of Richmond, really getting blasted in Bowling Green and Asheville and Fredericksburg and Manassas and southern. Look at the Tucson River, Tappahannock, dark blue here. Let me move this so you can see it. And then it extends into Salisbury and the Virginia Eastern Shore, getting slammed because of the north wind bringing down the cold air, right? Roanoke and Lynchburg still getting crushed with ice, freezing rain, heavy freezing rain. And the temperatures, let me blow this up a little bit. Okay, this is Monday at 10 a.m., 9 a.m. Richmond is still 30 degrees. It has not warmed up. North of Richmond is 29. Roanoke was 29. Lynchburg is 29. 25 in Stanton, and then 26 in Charlottesville, and 26 in Fredericksburg, and 24 in D.C. That's a cold temperature. Winchester is 22. Frederick is 22. In Baltimore, 24 degrees. Salisbury is 25. This is a cold storm. All right. Now, this is the midday, Friday European, valid from Monday. All right, 1 p.m. There's a dry spot that appears, punches up from western North Carolina. You still have moderate snow in the Delmarva and the northern neck, light to moderate snow in southern Pennsylvania, much of central and southern New Jersey, Baltimore, eastern Cambridge, Dover, Wilmington, and then again into Virginia Panhandle, Martinsburg, and then you have light to moderate snow in the D.C., Northern Virginia area. Richmond is a mixture of snow, sleet, and freezing rain at that point. South and east of Richmond, it's all rain in Hampton Roads and Williamsburg and Suffolk and Emporia and Rocky Mount, all down there. It's all rain. Temperatures around 40 degrees. Now, here's 5 p.m. What begins to happen is, remember we talked about those temperatures at 30 degrees. Okay. Now at 5 p.m., look what happens. The temperatures. Let me blow this up so you can see a little bit. They're dropping. Richmond is down 27, 28 degrees. Okay, by 4 or 5 o'clock in the afternoon. The north wind is coming back. The temperatures are dropping in the Shenandoah Valley. They're holding about the same in D.C. and Baltimore and the Delmarva. But on the backside, you can see the cold air coming in. The temperatures are down to 25, 29 degrees in Blacksburg and Roanoke and 26 in Lynchburg. It's getting cold again. And what's happening is the precipitation is filling back in. So this is the big change here. There may be a second part to this storm after we get this break on Monday afternoon. Please keep that in mind. A second part to this storm, Monday afternoon and evening, that a lot of forecasters aren't talking about just yet. But I think they need to start focusing on this. So notice the snow is picking up again call it my marker. No, that's not what I wanted. Great. Let me call that up again. Where it is. Here we go. There it is. Look at the moderate snow developing right here. Okay? And filling in southwest Virginia. Blacksburg may be going, Roanoke, all southwest Virginia, Bristol, Bluefield, going back over to snow. All right? Now, the dry slot is beginning to fill in here as the cold air comes back in. You still have decent moderate snow in southern Maryland and portions of the southern Delmarva. All right? And then here we go. Boom. Monday evening, 7 p.m. Now the snow is beginning to advance into Williamsburg and Suffolk. Okay, this is driving to the south. Richmond has got light to moderate snow. You got snow almost all of Virginia at this point in southern Maryland and the Delmarva. And then some moderate snow in southern half of West Virginia. Roanoke's gone over to snow. Or southwest Virginia, Blacksburg, west of I-77, gone over to all snow. All right, and the other thing I want to point out here is how long an event this is going to be. So here, this is the European model, again, from midday Friday, 12Z run. So now this first image, I'm going to blow it up here. This is Sunday, 7 p.m., okay? You can see how it stretches from way back west of Kansas City to southwest Virginia. Look at that fetch of moisture. Look at the ice storm in Kentucky and southern Illinois. Good googly moogly. This is a long duration event. This is all overrunning. This is all overrunning. This is the main storm here, but this is overrunning into the cold air. The warm air overrunning. So it extends from way back here, from western Kansas all the way through to southwestern and central Virginia. Okay. Now, that is by Sunday, 7 p.m. Now, this is the European model. This is the 18Z run, which just came out at 6:30. And look at this. This is now 10 p.m. Monday evening. You got light to moderate snow in all of Virginia, including the Richmond area. It's gone over to moderate to heavy snow, it looks like, according to this. And the low is off the coast, but look at the moisture still hanging back here. Normally, when you have a low this far east, you don't have this amount of moisture. But this is a very interesting, elongated system. And that's why the moisture hangs back like that. Look at this. Monday, 10 p.m. Moderate snow in the Richmond metro area. And the snow has ended in D.C. or very close to it. And you can see Western Virginia, Southwest Virginia. But this is the second burst here. And notice the snow is now pushed into Hampton Roads. Virginia Beach, Chesapeake, Hampton, Newport News, Gloucester, Suffolk. Maybe even Elizabeth City, if that's right. I don't know if it's going to stick with the rain on the ground, but it's there. Okay, so this was the 12Z GFS snowfall map. I posted this earlier, and this is the snowfall map. Now, what changed here is that the previous runs of the GFS had almost no snow in Richmond, Central Virginia at all, and very little in Charlottesville. So now you can see that looks like 3 inches south of Petersburg and about 5 inches north side of Richmond. That's not a bad forecast. Even has a couple of inches in Williamsburg and Gloucester and, the Middle Peninsula areas. Charlottesville, 6. Stanton, 7, and then you have the big snow up in D.C., Winchester, Frederick, Hagerstown, Germantown, Martinsburg, West Virginia, and you can see right along into Harrisburg, 10 inches in Philly, 14 inches in Millville, New Jersey, 12 inches in Dover. All very reasonable solutions, not bad. Notice it doesn't get to New York City, which again I think is true. I don't think it gets into New York City, but then you can see that's a 12Z run. This is a step in the right direction. Okay, now this is the European model. Okay, from early Friday morning, 6Z. Now, it has 4 inches south of Richmond, let's say Petersburg, 6 or 7 in Richmond, 11 inches in Ashland. Look at Charlottesville getting crushed, 14 inches. Stanton, 13 inches. You have 3 inches in Roanoke, but much higher, just in the mountains. Fredericksburg, 13 inches. Tappahannock, 13 inches. 8 inches in around D.C., less to the up towards Baltimore. But you can see that's the main band right in here, and it extends into the Delmarva. That was early this Friday morning. This is the afternoon run, okay, that came out. And now this is the British model. And it just, look at that, it just pounds Richmond. Pounds it. Biggest snowstorm since 2018. And the heavy snow stays out of D.C. It all sinks southward. Okay, 15 inches in is that Roanoke or Lynchburg? No, that might be Roanoke. I got to take a look at that. Yeah, wow. 13 inches in Lynchburg. I don't think this is right. I think it's too far south. But British model's pretty good. So, and again, you can see the west to east orientation. Now, in order for this kind of snow to occur, it's going to have to snow into Monday night. It's going to have to snow into Monday night. If this thing cuts out Monday afternoon, 5 p.m., these snow amounts are not going to happen. Okay? So keep that in mind, too. Now, this is the 12Z. This was the 12Z GFS model, which I showed earlier. You can see it's got the nice snow there. I showed that earlier. So I did not present the 18Z European. It's very similar. I'll post it on the website if you want to see it. When I post the video, you can take a look at it there. It's very similar to what is showing here at 12Z and the European, and showing it very similar. So that's it in a nutshell. Like I said, I don't think the GFS solution is right. At some point, either maybe Friday night to Saturday morning or sometime on Saturday, the GFS is going to say, holy crap, I'm an idiot, and have a completely different 500 millibar solution, and the other models will hold the same. And I think you will see a drop southward of the snow and a drop southward of the ice and the rain, and so it'll be a much colder solution, looking much more like the European and the British model. I could be wrong, but that's how I see it. I do think, even if it shifts south, I do think DC has an excellent shot of a 6 to 10 inch snowfall. So does maybe even Baltimore and Northern Virginia. I would not be surprised at all if someplace in Charlottesville, Gordonsville, Orange, Fredericksburg, Stafford, Tappahannock, Goochland, Palmyra could end up with 10 or 12 inches of snow. Would not surprise me at all out of this whole thing. Anyway, that's the summary. The first call map will be out Saturday morning, late morning, like 11 a.m. I got to send it to the clients first thing in the morning. But that's how I see it. We'll see how this changes. This is a very interesting situation. A lot to think about, a lot of variables here. But that's this video hopefully presented a general summary of why I think the European and the British and the Canadian models are correct and the GFS model is just Bravo Sierra. All right, thanks for watching. This is meteorologist DT from Weather Risk. I will see you over on the Facebook page, over on the website, and then over on Blue Sky and on the Twitter page.